Well, I am Eric Muhs. I am a physics teacher currently at Roosevelt High School in Seattle. And this is my friend Jim Day, who is a cabinet maker by profession and a jack of all trades. We're going to talk to you about our work with kite aerial photography in schools and the equipment that Jim invented and developed, and our experiences with it, and where we're headed with this business, away we go. As I mentioned earlier, I am headed to the South Pole in the end of the month, and this is under the auspices of the National Science Foundation. It's a program for teachers. Each year they send 6 teachers to Antarctica and 6 teachers in the summertime to the Arctic. I'm going because I've been involved in astrophysics at the University of California, Santa Cruz when I lived down here, and then lately at the University of Washington on cosmic ray projects. And that's all about, a lot of that work has been about getting students, able science interested students involved in doing this kind of work. And I was fortunate enough to be selected for this. It's been about a year and a half coming. I applied almost 2 years ago at this point. I'm going to go work on a very obscure astrophysics project. It's very exciting. We're rarely building, in some ways, the largest scientific instrument ever built. It involves, the project is, the prototype project is called Amanda, and that's sort of morphing into a much larger project called IceCube, because it will be a cubic kilometer of detector, instrumented volume in the deep ice of the South Pole. It involves melting 2-mile deep holes in the ice. But part of my job is to go as a journalist, not only as a scientist, to take pictures, to write daily journals and upload them, and bring students into the experience. And I was thinking, well, 2-mile hole deep holes in the ice, not much to see on the surface. Where's the interest for students? Talking about particles that they can't see, they can't experience. I mean, the word we always use when we talk about the neutrinos, what we're really after is either ghostly or elusive. So that's the whole astrophysics project. It's ghostly and elusive. So I was looking and thinking, well, what can I do that's more immediate and more involving for students? And as I referred to, through just internet surfing around a couple of years ago, I was aware of kite aerial photography. I said, yeah, this is it. This is great. I could build some rigs with students. I could fly kites to the South Pole. I could take some pictures. And during that time, I moved to Seattle, and I was searching around on the internet, kites, Seattle, and hit on the Draken Foundation. And I met Jim through the Draken Foundation, and they were developing a kite aerial photography project to do with schools. And over the course of the last, year and a half, we've developed this project and figured out how to get it in front of students in as inexpensive a way as possible. So that's what we're going to present today. That's kind of how I got into this. Just, to finish up with that introduction, as a physics teacher, we use a lot of equipment, and I'm really thrilled to see all this stuff. It's a little bit, I got to tell you, like a mad scientist convention. And it's very appealing. I've been going around taking pictures of all the rigs. I'm working with a robotics team right now, and one of our training projects is to build, we have 3 small groups in that big group of about 25 students, building 3 different competing kite aerial photography rigs. There's a lot of neat spin-offs, a lot of ideas I can take back for these guys.
What's the detectors for? What's the experiment for?
The experiment, the IceCube experiment is primarily aimed at detecting high-energy neutrinos from the most energetic events taking place in the universe. In order to detect neutrinos that you need a massive detector, and neutrinos, trillions have passed through your brain since you and I have been talking right now. I mean, the flux is enormous, but they hardly interact with ordinary matter. So you need enormous detectors. And ultimately, you know, people ask, what's the good of detecting these really ephemeral particles? And nobody really knows. but that's a good thing. I mean, if you think back on any kind of telescope, when Galileo first pointed a telescope up at the heavens and really thought about what he was seeing, I don't know if he was the first person to do that, but he was the first person to really think about it and report about it. It changed completely the way we view the universe. And every time we build a new way of seeing the heavens, it's opened up a new door that we didn't have there before. Radio telescopes. Lately, the last development has been gamma ray astronomy, and now we're trying to do neutrino astronomy. So, essentially, yeah. The interaction that neutrinos make as they pass through this very clear deep ice is they create Cherenkov light, tiny, very, very faint flashes of light which can be detected. But we won't do that. That's never going to happen. So what I'm going to show is some of the materials that we've developed for use with the kits and for use with the Draken Foundation. This material is just polishing off our education site, and this material will be available. Oh, there's Jim working with my students from last year. I guess this is on a time thing. The heart of this rig is a very simple spring-loaded timer, which we can't find more of. So anybody who has creative ideas about how to find timers like this, we are all ears. The rig doesn't quite look like this anymore, Jim. In fact,
no, we've modified the rig quite a bit, saved a fair amount of money on it, also lightened it by about 2.5 ounces. But this one was done a couple nights before the class was started, which was kind of a bad thing.
That's a good thing, because you're meeting deadlines, and that's what we do in teaching a lot.
But a lot of this was taken from Brooks's first rig that he did, first class that he taught.
Our suspension system currently is a little bit different than this. That's lightened up and simplified. In fact, we just got a strip of aluminum with notches in it. But it's a simple string wrap. And there's some of my kids in action. Classroom putting this together. So my job in this in particular has been to figure out how to write directions that anybody could look at on the internet or on a piece of paper and actually build this rig from the kit. So we really tried to do a lot of communication to bring this down to the reading level of a high school student, which is close to zero. In other words, it needs to be extremely, extremely visual. We gave a lot of thought to how this would look on the page and how to do this in as few words, as many pictures, and in as few steps as possible. We'll talk about this.
Well, we finally have it down to a simple package, and all the parts just put together, so you basically don't need any tools at all to put this thing together. As you can see. But we're trying to get the kids to build these things in class.
Yep. Part of the goal here is that this is very, very doable by anybody. And you know, I think all of us, it's very easy to look around the room and say, well, everybody has a finished product here. But really, when you start thinking about it, it ends up being the story that really is interesting, the journey of how you got to this point and where you're headed from there. And in some ways, this attempts to begin a story for a lot of kids who think, well, kiting is for little kids and their daddies, and that's about where it stops. But you know, to get more serious with it, to actually take some serious pictures is either way too complicated or not realistic. In fact, these kits, these rigs are really fun to use. I gotta tell you.
I'll be taking one to the South Pole, because you know how much can go wrong with this? Almost nothing.
Rubber bands.
Rubber bands, yeah, and I'll have a problem. I did check the temperature at the South Pole. Think of me next time you're cold flying a kite. The temperature Tuesday morning was minus 63. There was a 10-knot wind, and that brought the wind chill down to minus 93. So I'm hoping it's going to warm up a little bit. That would be late spring. The highest recorded temperature at the South Pole was minus 13 Fahrenheit. So I'll have my work cut out for me. If you're interested in checking out pictures that I'm able to do, look at the Draken site. There'll be a link to the place where I upload my journals and pictures, and it would certainly be very welcome. If you have other comments, by the way, or suggestions for flying in extremely cold weather, I would be delighted to hear them. So let's talk.
The other thing we've done with this is we've made it so you can put almost any camera in there, any disposable camera.
Yeah, as you may know, there are not only these quick snap outdoor cameras, but there are automatic flash cameras. You could try shooting at night. There are panoramic mode, and it's a great way to get into it. What I've found with this rig is the pacing is really, really beautiful and fun, because really, first and foremost, you're flying a kite, and that's probably how a lot of us started doing this. And then you get really tech down. Are my batteries charged? Am I on the right frequency? And really what this is hanging from a kite. You wind up the timer. You wait. Maybe you can hear it on the kite string, or maybe you just wait 10 minutes. Then you walk down the string, wind it up again.
Yeah, sometimes you just get a picture of yourself.
As you're walking it down, yeah. And then you let the kite carry it up again, and the pacing is very, very nice. You can have a sandwich or talk to somebody while it's taking the pictures. We've also developed, to go along with this, a version of Delta Conine kite that is really easy to do. As we thought about this, well, you needed to really be able to supply students and teachers with a kind of a kite that was super cheap and would go in the air the first time they tried it. Student frustration level, any of you have small kids know about this. It's got to work right the first time, or they're going to walk away from it. So we've put together a set of very visual directions on how to build this kite. On the website, there's actually some pictures of the kite flying, so you can get a sense of how it performs. A lot of this is done with staplers, which are really ubiquitous in the schools, great joining material. And just quickly marching through there. And what we found with this kite is it's really tolerant of small imperfections, very easy to fix, very easy to adjust bridling for different wind conditions, and it's reasonably stable and a good lifter. And there's a picture of the kite actually hanging upside down from the ceiling. The foundation is selling the kits, the disposable camera kits, this entire with a camera for $25. The Tyvek to do this kind of kite is $7, and that's really pretty reasonable. Just makes a nice durable kite.
We went through a series of different kites. We tried a Rokaku and found the kids had troubles bridling them. So then we went to a Delta, and it wasn't consistent. The kids had troubles making the kites consistent. So we ended up with a kite that's just about foolproof.
One
thing.
The great problem we had with the Rokaku was the knotting and trying to teach kids how to tie knots. If you've ever done this, it's a tough business. Having them staple, much easier. So there's that. And another project. Do you have anything more to add on these rigs? Okay. We certainly. Would you like to show your silly putty timer? That would be a great thing if you could jump in right now, leave that camera alone. The timer issue has really been a problem. We started off with 200 nice egg timers, which.
Well, they're actually silent phone timers that are deafening. They're very loud.
And is that the guts of this timer?
Right.
Right here? Okay. And then the supplier had no more of these spring-loaded timers. In fact, if you get on the internet, you can search for hours and hours and not find any reference to spring-loaded timers to get anything like that. And that has created a supply problem. There are other ways to time. One of my jobs coming down here was to actually find out about the silly putty timer. We'll get a demo of it from David. And this may be a solution for what we need, but we certainly need to find something very cheap and a lot of them.
This is a neutrino detector.
It's a photon detector. How's that?
I'm David Hunt. I didn't get a chance to introduce myself. I'm from Tennessee. And this is the most complicated thing I've ever done. Because I had to teach a bunch of kids how to do it. So I really appreciate what he is doing with the kids. There's a different thing altogether. The timer,
Yeah.
the timer on this camera came from the free flight airplane community. Something they use to dethermalize their airplanes. And if you can see it on the top here, this is basically Brooks's rig. It's two aluminum tubes. There's a bigger one and a smaller one that is inside of it. The inside of the bigger one is filled with silly putty. Now, those of you who are not from the United States, good luck. I don't know how to explain it to you. Silly putty is basically like chewing gum. You would roll it up and set it right here. After 10 and 15 minutes, I don't know, depends on how cold it is. This won't work.
No.
And it would eventually melt into a little pebble. So it's got a very high viscosity. And it's got some other properties too. But there's basically a little nail that sticks through the inner tube. This is got a rubber band on the shutter. This flips up on the nail. You just twist it straight up, gives you a little over 2 minutes at normal temperatures, and you send your kite up. And that, well, I'll do it a little shorter time, maybe you can see it moving.
And then the silly putty will draw it back to its original position.
The rubber band is putting tension on that, and the silly putty is resisting the tension of the rubber band. And so slowly, closer to here, I don't know that we can see it, it'll slowly pull that down.
So it's like a failing adhesive.
Yeah.
It's like an adhesive that's failing.
Right.
Gradually releases it.
gradually releases it. You can see it's slowly coming down. I'm sure this is very temperature dependent.
What would the delay be at the South Pole?
Not long enough to take one picture like that. Does the silicate wear out? Do you have to replace it from time to time, or it stays pretty gooey and nice?
Tube diameters are widely divergent. It doesn't run out the end. I know that.
Well, yeah, so you wouldn't want to store it with the end down, it would eventually run out. So make sure you store it like this. It is slowly coming down, and this is, each one's different, because when you start shoving that stuff in there, depending on how much air you get it and how full you get it, you have to calibrate your own time. But this is fixing to slip off here. And
So is this a single release?
single release.
On camera?
There we go. And it's lots of fun if you've ever used a manual rig, up and down and up and down.
And then the fun part is figure out if you got a picture of it.
Yeah.
Right.
And when it actually happens.
You have no idea, and then where I live, the wind's real very, I don't know, possibly the person who told me, somebody emailed me the website that had this design, and I forgot who it was.
I have a copy of it's a PDF file.
Right.
And I have a copy, it's called Cheap Cat. You can search for CHEAPKAP.
That's on my,
Okay,
well, that's
his
my
website.
website.
Oh, that's your website? Well, then I downloaded that for you.
Well, actually, it's on Peter's, because my free web host won't let me store PDF files. So Peter,
You will find it on that.
yeah, the link is off my site today, so.
I have a copy of it, too. I can email it to anybody that wants it.
And it's printable, but I don't know how good it works.
Now, I had problems with, there was supposedly you could rotate that. You could rotate that manually for up and down.
This?
The planet,
The camera.
The camera to get it to look down.
You just start bending the wire.
Bend the wire.
You know, you don't even worry about keeping the pick and bay horizontal, just get it to where your camera points the direction you want. And it's just a coat hanger, and you just start going. I show it on the website like this because it looks good. By the time you start using it, it looks all sorts of ways. So, oh, yeah.
Tell us about your students. I'm interested in, so once you strengthen and heights and they get raising it up, what kind of photographs are you taking? How does that use, the school projects?
Kite aerial photography is not the primary motivating force of most teenagers. We know what that is. And so, to be quite honest, last year I worked at a private school where I had a very small class of about eight or nine kids, and we took some pictures. And with the disposable rigs, it's a surprise. You get what you get. You're lucky if you get one pretty nice picture per. So we did we took some days outside the classroom, went to parks and shot some stuff. And some of the kids took their rigs at the end of the year, and we don't know. Maybe we'll see great things on the internet 5 years from now, or not. This year I'm back teaching in a public school, and it's much harder in some ways because the class sizes are much bigger. But where I think we're headed is developing an engineering physics and engineering science class, because we have this big robotics program and all this can fit in, and I'm hoping that this actually will be a springboard for that. But in some ways, when you put stuff out there for students, it's a matter of exposing them, and maybe you light one or two fires, and a couple of them really take off. I had one kid that was quite interested and shot several times with me, and the rest were, but they were like that about everything I put in front of them. So, it's not like this was a bad project.
Drocken's also, there's a traveling KAP exhibit that's gone out, and these are going with them. And so what they're trying to do is teach teachers to teach it. So we'll see what happens. We don't know exactly what will happen. But it's real hard to, it's easy in the class to sit down, build the rig, and build the kite. But it's hard to walk outside and get instant gratification. We tried with Eric's class, and the wind was blowing, and we're in the middle of the city. They go out to the soccer field, ground's soaked, the buildings are all around. Kids don't know what they're doing. You're just dodging kites and cameras. Just getting the kites to the field was a real problem. But more, we're trying to open up something for them. And whether they've got to basically go out on their own and play with it. Because we can't, some days it blows, some days it doesn't. And all you can do is give them the tools to do it if they want to do it. But this traveling exhibit has been real fun. And I guess it's been pretty popular. It's in Florida right now.
In fact, that brings me to the other thing I was going to wrap up with to a certain extent. This is a CD that is showing for that exhibit. It sits on an iMac, and it has limited navigation, and there's a gallery of some really nice photographs that some people in the room here have taken. And I would be happy to set up my computer and allow it's on the computer and you can take a look at it. There's some quite nice stuff. I think right now that's in Tampa at a science museum there, and then it goes to Chicago and Colorado Springs later in the year. So this exhibit is traveling around. The entire CD, the contents of the CD, will be available at the Draken site hopefully very soon as well. One of the things that's on it that I realized this group would be quite interested in is the entire contents of the French KAP team from 1917. We have that digitized, and perhaps I'll run that. We'll get
Which also has the photo lab where they developed it right there in the
yeah,
field.
we'll see the whole thing here.
But all we're trying to do is get more people, get the information out to people.
And according to the documentation we had about this film, was there were very, very few photographic opportunities from the front during the First World War. It was information, as it is now, was very highly controlled, and it was very hard to take pictures of the First World War that were anything but horrific and ugly and made people want to stop fighting. So this would have been sort of like trotting out the most high-tech weaponry on the news imaginable. This was a newsreel that played in theaters. Look at our great army. Look at the high-tech, groovy stuff they have. See, they're motorized.
The thing they're towing is the dark one.
There is a section of this film which is about balloon aerial photography, which is interesting in its own right, but for the sake of size, we cut that out of this presentation.
I can add some explanation on that movie. In fact, there was French teams in the French army, and there was not so many people really training for that. And the problem is when they send them where the place they were supposed to do the photographs, for different reasons, they were sending the equipment in one way, the people were running in another way. It was sometimes difficult for them to find the good place right to fly the kites, in fact. And even if there are many experiments, many soldiers from the training team were sent to another place for fighting. And many teams were not really able to do what they were supposed to do. And this is only one example we have on training. And this is a new thing, you can see they were normally trained to do that. But as you can see, there is some uncertainty, they don't know really what to do. It's not, they don't look to be very experienced. And if you look and relook this movie, and you find things like that.
This scene is entitled, How Many Frenchmen Does It Take to Assemble a...
Oh, boy. I admire that they're doing it all in trench coats in the sun. With guns, yeah.
With gas masks.
And so you have to know that at that time there were kind of competition in different teams. There was the Sapone team, there were other people teams, and they were competing to know which one the French army would choose as the best one. And as everywhere, it makes trouble, of course.
Presumably this was good duty compared to being in the trenches.
The French are very excellent at that.
Until the guys are couldn't say.
Yeah.
Assembler ce contrat sur
So we have, I think, 5 or 6 of these CDs, which we will include in the auction or the giveaway. But this material will be available on the educational part of the Drachen website.
How do you spell Drachen?
Drachen. It's drachen.org. And I had also meant to mention while I had the floor how important it is to people that are just maybe getting interested in this to post your work on the internet, find a way to do that, and show what you're doing. People come into this in all kinds of pretty obscure ways or random ways, and that's certainly how I got interested in this.
Yeah, the start is not too bad, and then you will see the wheel system. As you can see, there is no wind that day, because the way they just take the kite is no wind at all. If you are carrying such kind of kites, as big as one, even with gentle breeze, you cannot hand it like that. So there was no wind at that way. And,
Now, in this part of the film, they're actually suspending the camera from their balloon apparatus. That's cleverly edited out here, but it's in principle the same.
Ralph, that's bigger than yours.
You know, I don't have any documentation on that. It looks like there's a large gear. Well, they're actually carrying a gas tank for inflating the balloon. The balloon came along with this whole rig.
This is a hydrogen balloon?
You know, probably at that time,
They're
yeah.
rushing the film now.
Yeah, this is the amusing part of the thing, if you didn't get a chuckle before.
The digital is just now catching up to the technology that they had.
No idea.
Now, if you look closely, you see
Yeah, funny, but
That's a good place to spend World War I inside that little booth there.
125 degrees.
Okay. And then,
This is the original 1 hour photo. We're off to lunch.
yep. And as I said, that's on the CD and will be available on the internet pretty soon. Any comments or questions about what we're up to? Yes?
You mentioned that that's the rig that you're bringing up to the fire pit?
No. Jim has helped me build an RC rig, and I will take one of these because I will get some pictures with this. It doesn't depend on batteries. I will probably take some super cold weather rubber bands, which are
Yeah, and I was thinking
What?
that the cold weather contraction of your plastic fittings on top of other components like the wood and your metal, they might contract smaller, you might split. So you might want to check that before you go.
I might, yeah. It certainly has been a concern, particularly with the plastic getting very brittle.
This is from cold weather experts.
Okay, you've seen it happen.
the other end of the world, though. He's done it up on top.
That's certainly very helpful. How cold were you flying in or shooting in?
Well, when we fly in winter up in the Ottawa area, we're minus 20 at sea. So,
Yeah, that cold.
That's zero gravity.
So would you recommend just stripping all the plastic out of it?
Like plastics with Wilson or...
Kids love a bucket of liquid nitrogen and put stuff in like that and see what happens.
Okay, because I think the bin that we got the plastic parts out of at Tacoma Screw Products, it didn't have a temperature rating for these, did it? So we'll have to ask the clerk.
Worry more about plastic being wrapped about on other things. If you've got plastic at both ends of the dowel, right? Is that right?
Yeah.
So you're having a dowel inside the plastic might contract more, and it won't want to split open.
Oh, okay.
There is a website out there about somebody who's building those hospitals to use it, the weather station at Hanging Village in South Florida, where it's a very, very full market area, and you have some hints that you might want to look up on how to do it. He said it's very difficult because to try and set them up intentional lines, you can't freeze while you're doing it. So you have ways of setting up the rocks so that you can do it even with gloves on. And so that was another. It's on one of the top sites. I can find it.
That would be great. And if you have more ideas or information, I would be happy to give email addresses or send them. If anybody's interested, I also have my computer here, obviously, and would be happy to take your email if you're interested in getting the journals and pictures sent to your website if you're interested in that. Ultimately, I think, the shooting time that I can spend outside is going to be limited by batteries as much as anything else. I'm picturing is, I may be down to 5 minutes of effective camera time, and then, just bring down the camera, back inside, warm it up, and try again.
Where exactly are you going to be standing? Are you going to be actually at the physical South Pole?
Yeah, the United States has a year-round station at the South Pole, and that's where the scientific project I'll be working on is.
You're going to be living in a closet back there?
Yeah, they're called Jamesways, and they're really pretty funky.
I know a guy that's at McMurdo 9 months out of the year.
McMurdo is very plush by comparison. It's been described as a cross between a college town and a mining town, if that gives you an idea.
There's some great parties there.
Yeah, there's several bands that are going, and yeah, South Pole is altogether more Spartan. Yeah.
I have some comments, Eric. Way
Yeah.
back. Obviously, you thought about the cold, which is a serious
lot.
problem, and actually I'm quite envious of your opportunity to try this. Have you considered the elevation at the South Pole? It's a high altitude site.
Yeah, it's the density altitude puts it up around 12,000 feet. If the pressure gets really low. On the other hand, the air is so cold that you've got some density there. One of the kites that I'll be taking, I think, is an enormous Delta, which has superb lifting power and it's pretty stable. So I'm more concerned. I mean, of course, can be ridiculously windy at the South Pole too. So I'm looking for a couple of good days and a couple of good moments, really.
How long will you be there?
I'll be there about 3.5 weeks, unless the weather turns bad. Teacher went last year, got stuck an extra week, couldn't get in, couldn't get out. But he certainly wouldn't have been flying kites had he been so inclined at that point either. Yes?
So Eric, what's the likelihood of it being sunny? Is it pretty good when you?
I didn't hear the whole question.
What's the likelihood of the sun being out when you go out?
There's a if you're interested, if you search on South Pole webcam, the University of New South Wales maintains a 24-hour webcam, and of course the sun's up 24 hours a day at this point. And the last couple times I've checked, it's looked very pleasant till I read the weather report and see what pleasant looks like. Weather's been pretty good. It can turn very, very funky in minutes.
Do they use solar energy yet?
No, because the sun is pretty low in the sky. What they use is jet fuel. Everything, including the melting of the holes for the astrophysics project, it's all run on jet fuel.
So you need a jet fuel powered rig.
Or a jet fuel hand warmer, yeah.
If you think about what's in rigs, any kind of battery technology, as it gets colder, the reaction rate slows down. I mean, that's what's intrinsic in micros, lithium batteries, you name it. So maybe you need a chemical powered way to warm your batteries.
Strap some hot hands on.
Yeah,
I mean, fuel powered.
That's part of it. I'm very limited by the amount of weight I'm allowed to lug down to the South Pole. It's very restricted. I've thought about taking the chemical hand warmers, and ultimately, you bring your camera out for a few minutes. You know about this, and most of the time, the camera is the last thing to go on, and you're, holding it. It's inside your parka somewhere, and I'll get what I get.